Hello, myself Ruchi Patidar. Today I am discussing about two topics. First is macromolecule and rubber elasticity, and second is goal of protein physics. What is macromolecule of rubber elasticity? Biological macromolecules, protein and nucleic acid are very complicated. Their properties in living system are governed by the totality of structural feature, in particularly by the fact that they are informational macromolecule are serve as text. It is important to establish how the behavior of biopolymers is associated with the varied fact of their chain structure, irrespective of the particular atomic groups that enter into the composition of particular atomic groups that enter into the composition of the macromolecule. A simple non-informational chain of the synthetic polymers serve as model for the investigation of the problem. The physics of macromolecule is one of the foundation of molecular biophysics. Polymers are synthesized by chemical method or are produced of their valuable physical properties. In engineering, polymers are used as plastics, insulators, fibers, and rubber-like material, natural and synthetic rubbers. The simplest synthesis polymerization of polyethylene. This is a structure of polyethylene, which is produced by polymerization of ethylene. This process involves the rupture of double bonds. The analogs of natural rubber synthesis, cis-polyospirin, is prepared by the polymerization of isospirin. A number of polymers, say nylon and seminal polymers, are produced by the process of polykondensation, which takes place through the elimination of some low molecule compound. A specific property of polymers, which is the most important to biophysics, in rubber elasticity, defined as the ability of a block rubber-like polymer to undergo large elastic deformation amounting of 100 of percentage at low elastic modules. Like other elastic bodies, natural rubber obey Hooke's law. On small deformation, the stress is proportional to the strain. This is a structure of stress or strain. And next is, where is the stress? L and LO are the length of the stretches, and under from the sample, E is the modulus of elasticity from steel 20,000 megapixel and from rubber and elasticity. Clapeyron equation, PV equal to RT. Next is where LO and L are initial and final position of piston. The work individual in the extension of rubber by a length dl by applying a force F is given by expression, where F is free energy, E is internal energy, S is entropy. Rubber is particularly in the elastic force on isothermal extension of rubber is equal to. Let's compress the gas content cylindric with a piston at constant temperature, increasing the pressure by an amount dP. The volume will decrease by amount dV from equation that where LO and L are initial and final position of piston, respectively. Equation is analog to equation, the only difference being that the role of the elastic modules, E is played by pressure, P the atmospheric pressure corresponds to E 100 kilogram. This being of the same order of magnitude as the elastic modules of natural rubber, the ideal gas is heated on abiotic compression in an analog way. Rubber becomes heated on adiabatic extension. The work involved in the extension of rubber by length dl by applying a force F is given by the expression. Where F is the free energy, E is the internal energy, and S is the entropy. Rubber is partially incompressible. The elastic force of isothermal extension of rubber is equal to F. In this lie the fundamental difference between the rubber elastic of a polymer and the elasticity of a solid body, say a steel spring, the latter being determined by the change in internal energy. But why does natural rubber resemble the ideal gas? The entropy nature of the elasticity of an ideal gas implies that when the volume of the gas decrease, the number of impact of molecule against the wall increase. The elastic force is determined by the thermal motion of molecule. The compression of the gas reduces its entropy. Since the gas passes from a more probably rare filled state to a less probably compressed state. Therefore, the modules of elasticity of an ideal gas is proportional to absolute temperature. The fact that the modules of elasticity of natural rubber is proportional to absolute temperature, which follows from equation, is also an indication of the entropy nature of rubber elasticity, indicating the natural rubber is composed of a large number of independent elements subject to thermal motion. The transition from the more probably arrangement of this element to the less probably, the more probably arrangement of this element to the less probably, the property of rubber and those of an individual gas may consist only in what has been said. But what are these elements? What plays the role of gaseous molecule in its natural rubber? The difference between macromolecule and small molecule consists primarily in the macromolecule are built up of a large number of identical links united into a linear chain. As a rule, macromolecule contain single alpha bond such as carbon-carbon bond, carbon-nitrogen bond, carbon-oxygen bond. There are possible rotation of atomic groups about this bond. The rotation about single bond give rise to various conformation of the chain. A macromolecule possesses a conformational lability, various degree of flexibility. The role of independently moving element is playing by chain segment which perform independent rotation. As we shall see, the conformational property of biological molecules are natural rubber. Following this path, we shall in the final analyzing come to the understanding of the nature of enzymic activities. Landau said that the objective of physics is to establish new relationship between seemingly unrelated remote phenomena. We have already established what relates natural rubber to an ideal gas. Further on, we shall see what related an enzyme to natural rubber. And my second topic is internal rotation and rotational isomerism. Classical origin chemistry considered by the rotation of atomic group about single bond to be free. Any conformation, say the ethene, that arise as the result of internal rotation have the same energy. No energy is required for the angle of rotation to be changed. Some of the conformation of ethene are studies of the thermodynamic properties of ethane and other compounds with single bond, and also structural investigation carried out by spectroscopy method, NMR, etc. have however demonstrated that internal rotation is not free. In nearly all cases, the ethane molecule has a lowest energy in the state to transformation conformation and a higher energy in the fully scalp conformation. For the carbon-carbon bond to be rotated by 120 degree, example like for the transition of one trans conformation to an identical one, an energy barrier equal to 12 gram molecule just be overcome. For ethane and also for the other molecules with an axis symmetry of C carbon. The dependence of the potential energy of the molecule U on the angle of rotation can be expressed approximately by formula. U is the highest of the potential barrier. The value of U increase when the hydrogen atoms in ethane are replaced by more bulky atoms are grouped and decrease when the axis of rotation is elongated. Some experimental values of a U are listened by the potential energy of internal rotation is determined by the weak interaction of non-bonded atoms R group. In ethene, this is the interaction of the hydrogen atom of the carbon group with those of the other carbon group regards quantum mechanism calculation. Formidable task. This two-factor makes the trans-conformation more stable. Principle of strategy is bond. The interatomic repulsion can be intermolecule interaction on the distance between molecule for model substance. The more difficult to evaluate the bond-oriented effect. A crude estimate can be obtained if we assure that in ethane, because of the small van der Waals radius of the hydrogen atom, the function is entirely determined by the orientation effect, and that the same effect is operative in ethane. The quantity U respect the energy of van der Waals force interaction between non-bonded atom and separated by the distance. It is clear that depend on van der Waals force. If the bonds are non-polar, then is composed of the energy of dispersion force and the energy of repulsion. If the interaction involves polar molecule of a group position dipole moment, then along with the dispersion force that operate electrostatic force, oriental and inducing force, all the three type of forces depend on the distance in the same manner. The corresponding energies are irreversible proportional to R. The energies of van der Waals force repulsion depend on the distance even more strongly since the repulsion is subsequently strong at small distance. It may be assured in the approx way that repulsive energy is inversely proportional to radius. The total energy of van der Waals force interaction of atom, molecule or group may be respected by following formula. This is the Lennard-Jones potential. The shape of the corresponding curve, the interaction energy is at a minimum and is equal to as to separate of the potential in empirical. Other potential have also been proposed. In particular, the repulsion may be repressed by the exponential function. The produce another empirical parameter, namely present the Lennard-Jones potential parameter for selected pairs of atom. Calculation of the energy of internal rotation are based on the assumption the intramolecular non-bond interaction are the same nature as intramolecular interaction. For example, kinetic Gordoxy worked out from the purpose of method of atom to atom potential, which had been developed by him early to the calculation to the energy of molecule crystal. The empirical parameter used are the equilibrium distance between non-bonded atom. Beside, it is taken into account that is molecule the potential have no spherical symmetry. For example, the equilibrium radius of a movemental atom depend on the angle found by the radius and the valence bond. Thus, a further parameter is introduced. We shall return to the calculation of the conformation of molecule in the next molecule. Unlike ethane has no axial symmetry, the curve can no longer be described by the formula of the type, for example, for the formula of butane. The curve representation in the dependence of the internal energy of this angle of rotation above the central carbon to carbon bond has the shape. There are three energy minima. The first is lowest at correspond to the conformation, and the other two are the same value of correspond to conformation produced by rotation from the transconformation. At potential barrier highest of the order of 10 kg, per mole. The time of rotational isomerization, example, the time required from one rotamer to be converted to another is of the order of 10 to the power second. This estimate is obtained through calculation based on the theory of absolute reaction rates. Hence, rotamers cannot be separated. Their presence and fraction and found by studying by the physical and chemical properties of mixing of rotamers. The spatial structure of rotamers is varied according the variable spectra are also different. Hundred and thousand of variation frequency occur during the lifetime of the rotamers. The rotamer has enough time to display the spectrum. As a matter of fact, the existence of the rotational isomerism was first established by correlation with the aids of Raman spectra. The ratio of the spectral lines intensives, which corresponds to different rotamers, depend on their content in the mixture in according with formula. The information of rotational isomers can also be obtained with the aids of radio frequency spectrometry, NMR electron diffraction, measurement of dipole moment. The theoretical calculation of the value of E is naturally carried out by the same method that are employed from the calculation of potential energy buried. If the energy of the system depend on several angles, uh, the multidimensional energy surface is calculated rather than a curve of the type of energy served in the kind of contour map. Such potential energy surface will be described in decision is conformation of protein. It should be expressed that there is fundamental difference between the conformation and configuration of the molecule. In the last, what is macromolecule? Macromolecule, any large molecule created from repeating subunit. Biological macromolecule are referred to as biological molecules and including carbohydrate, lipids, nucleic acid, protein, etc. What mean by elasticity of rubber? Rubber elasticity, the capacity of substance, very large deformation followed by complete recovery. What is internal rotation? Rotation toward the midline along a vertical axis. The normal range of motion is 70 to 90 degree. The internal rotation muscles are the subscapular, uh, pectorals major and teres major, and the anterior accept of the deltoid. And last is, what is rotation isomerism? Rotation isomerism is one of the basic concept of spectrochemistry. It referred to isomerism that is due to the difference in spatial arrangement of atom, affording distinction between stereoisomers that can be interconverted by rotation about formally single bonds.